there's more than one event, and the result of one does not affect the other. Whereas over here, dependent, the probability of that second event is dependent on what happened in the first event. Okay, so let's do a quick do now, just as a review. We did a couple different problems yesterday. I don't think they were quite like this, but same idea. We have a piggy bank with 10 quarters, 5 dimes, 3 nickels, and 2 pennies. Again, I always like to find the total number of coins. So here I've got 15 plus another 5. So I've got 20 coins. And again, if you'd like to hit pause and just try this on your own really quick, that'd be great. So what's the probability that you don't select a penny? So the probability, you could just say it, of not a penny. Well, remember, my denominator is going to be, I've got 20 coins. What's the probability that I reach in there and I don't grab a penny? So since there's only 2 pennies, that must mean there's the 18 other coins. So the 10 quarters, the 5 dimes, the 3 nickels, all of those are not pennies. So that's 18 over 20, which would give us 9 over 10. So you can think of it as a 90% chance, but remember, probability, we usually think of fractions between 0 and 1. Select 1 Chinese yuan. So what's the probability of selecting a yuan? That's the currency of China. Well, there aren't any of them in there. So there's no yuans in there. I do have 20 coins, but that's obviously 0. And then you select a penny or a quarter. Remember, we learned about the meaning of or yesterday. This really means, you could think of it as more. So the probability of a P or a Q, well, I get to add them, right? I get more. I win if I select a penny, but I also win if I get a quarter. So a penny or a quarter. Well, there's 2 pennies, and also there are 10 quarters. Still just 20 coins. So that's 12 over 20, which would be 6/10 or 3/5. So a 3/5 chance, or a 60% chance. Okay, so we are going to now move into independent and dependent. We're going to jump right into it. So again, you could pause anytime and write this in your notes. And I would encourage you to write this right here. Hit pause and write this. 2 events are independent if the outcome of A does not, this is the key part, does not affect the outcome of B. So in many cases, when you're dealing with either drawing marbles out of a bag or money out of a piggy bank or cards out of a deck, you might hear this word with replacement. That means whatever you picked in your first event, you kind of put that card or marble or coin back in so it doesn't affect the second draw. Okay, so independent, you'll hear this phrase with replacement. And notice that our probability is a little bit different here too, because there's 2 events. What's the probability of A happening and then also B happening? Okay, so the probability of A and B is the product. You can see it's a multiplication sign. The product of the probability of A times the probability of B. So let's look at a couple of examples of independent. Okay, a coin is tossed and a 6-sided die is rolled. Find the probability of getting a head on the coin and a 6 on the die. So if we use our formula, we got probability of a head and a 6. We know from right above here, if I look back up there, that's the probability of getting a head times the probability of getting 6. Probability of a head obviously is 0.5 or 1/2. Maybe actually let's write that as 1/2 so we have fractions. Sorry. Times the probability of getting a 6 on a die is 1/6. There's only one 6, and there's 6 total faces to a die. So that is 1/12. In fact, if you have a coin at home and a die, I would encourage you to try it. This is a pretty low probability. 1/12 is like 0.08, so about 8%. So try to flip a coin and get a head, and then also roll a die and get a 6. Both things have to happen. So if you flipped a coin and you got a tail, you lose right away. If you flip that coin and get a head and then you roll the die and you get a 3, you also lose. So try to do both and you'll realize it's pretty rare. 1/12. Okay, let's look at the next one. Actually, we've got some colors here. So a jar of marbles. We've got our favorite. In fact, we had this yesterday, so I know that there's 12 marbles. Okay. We've got the 4 blue, the 5 red, the green, and the black. Or sorry, 2 black. A marble is chosen at random, and then after replacing it. So that's a key phrase. After replacing it. You see that? And you should think, oh, independent. Because whatever happens on my first pull, I get to put that marble back. So it's like I'm starting all over again. Then that second marble is chosen. Okay, so probability of getting a green and a red is the probability of green times the probability of red. Well, the probability of green is 1/12, and the probability of a red is 5/12. So that gives me 5 over 144. You can put this in your calculator. That's a really small percentage, much smaller than 1/12, and probably half of 1/12. So that's about less than 5%, probably like close to 2.5%. So this is really small. It's pretty rare that you're going to and then part of it is because there's only one green, and even if you get that one green on your first draw and you put it back, then you still have, 5 out of 12 is less than 50% chance of getting a red on that second one. Okay. Probability of blue and a black. So probability of blue, I have to spell that out since they start with BL, and a black. Well, the blue is 4 over 12 times the black is 2 over 12. Gives me 8 over 144. That reduces, I know 2 goes into 8 4 times, 2 goes into that, what is that, 72? I can keep going, 4 goes into that, 1, 4 goes into that, 18, I think that's 1/18. So we've got 1 over 18. You might want to compare that to 5 over 144 and see which one's smaller. That might be interesting. Okay, but both are pretty low probability events. And again, the whole key was for independent, we replaced it. Okay, last one. Oh, we've got the deck of cards. I do want to go over this briefly because here. Notice again, we see the phrase with replacement. I want to make sure you all understand. You may not quite be able to see this. The deck of cards has 4 what's called suits. Clubs. These are called spades. Those are the 2 black suits. Then these are hearts. And these are diamonds. Those are the red suits. Okay. Each suit has 13 cards. So they each one of these has 13. So there's 13 clubs, there's 13 spades, there's 13 hearts, there's 13 diamonds, for a total of 52 cards. And then you could also see, looking at it this way, there's 4 aces, there's 4 2s, there's 4 3s, right? There's 4 of each number, and then these face values over here, we've got the jacks, we've got the queens, and we've got the kings. Okay, so let's look at some of these. Just one question. Whoa, I'm sorry. We just finished this one. What is the probability of choosing an ace, a spade, and a 4? And you replaced after each one. Okay, so the probability of choosing an ace and a spade and a 4 is, well, the probability of choosing an ace times the probability of, oh my goodness. Probability of choosing the spade times the probability of choosing a 4. So the probability of choosing an ace, well, there's only 4 aces over 52. But then you're going to put that back in. So then when you try to draw a spade on your second draw, there's still 52 cards. And there's 13 spades. Remember over here, spades, we got 13. Then, regardless of what you got, then you're going to put it back in. So you still have 52 cards on your third draw, and you're trying to get a 4. If you look over here, obviously there's 4 4s. And you could multiply that all out and reduce. You could actually kind of reduce it a little bit right here. 4 over 52 is 1/13. This is 1/13. And 13 over 52 is 1/4. So you could multiply that all out, and you'd get 169 times 4. I'll let you do that math. You can also use that fraction reduction strategy in your calculators. Okay, I want to jump to dependent. So 2 events, again, you can pause and hit the pause button and write this down in your notes. But for 2 events, when they're dependent, A and B, they're dependent if the first event does affect, right? So now you might see the word without replacement, right? You draw something, you pull a card out of a deck, but now if you keep it, so if you don't replace it, now you have less cards, so the probability changes because your denominator changes, okay? Okay, so now you have a drawer, 4 green gumballs, 7 red gumballs, and 11 yellow gumballs. Remember, see our total, that's 11 plus 11. We got 22 gumballs. Okay. If you randomly pick 2 gumballs from the drawer, what is the probability that one will be green and the other will be red? And again, we are not replacing. So we want the probability of getting a green and a green and a red. Well, the probability of getting a green, we see that's 4. So we got 4 out of 22. But this is the critical point. When we don't replace it, on the next draw, there's only 21 gumballs because we just picked one out. And how many red ones? There's still 7 red ones. So we'd have 4 over 22 times 7 over 21, and you could multiply that out. And I'll let you decide and factor. You can kind of reduce a little bit now. This is 1/3. 4 over 22 is actually 2 over 11. So this is really 2 over 33. Okay. What is the probability that you will pick 3 yellow gumballs in a row? So probability of picking a yellow and another yellow and another yellow. Well, the first yellow, remember we still only have 22 to start. We've got 11 yellow. So 11 over 22. But then when we pick again, there's only 21 gumballs. And if we picked a yellow one, how many yellow are left? Well, only 10. Okay, then on our third pick, again, we did not replace. This is why it's called dependent probability. We only have 20 total, because we've already picked 2, right? We picked one here, we picked one here, and if they're both yellow, and we started with 11, now there's only 9 yellow, okay? And then you could find what the reduced fraction is on that one. So those are a couple of examples. Lastly, I just wanted to show one dependent with the cards. Okay, what is the probability? Again, you see the words without replacement. So if I don't replace, that means it's going to be dependent. My denominator is going to change. Dependent. What is the probability that both cards will be a king? Well, I know there's 4 kings. So I want the probability of a king and a king without replacement. So 4 out of 52 on my first draw. But then whatever card that is, I'm going to keep it. So on my next draw, I only have 51 cards. And if that first one was a king, how many kings left here? 3. So again, you could kind of reduce this a little bit right here. 4 over 52 is the same as 1 over 13. 3 over 51 is the same as 1 over 17.